Hello, television audience. How are you today? Thank you for joining me for this episode of our machine learning series. So, have you ever wondered about how logistic regression works? It sounds like linear regression. It's a machine learning method, but how does it work? And what's it used for? What's it good for? Well, let's talk about that. So, like other predictive analytical methods, logistic regression can be used to make predictions about potentially costly or beneficial outcomes. So when it's applied, it can help a healthcare organization get ahead of the game by creating opportunities to improve care or decrease costs by identifying those risks or opportunities on a case-by-case basis. So what you're basically doing is using historical data from your database and the natural relationships that exist among those data fields in your database to predict values for data fields that you really care about, that are valuable to you, and that may be hard to get values for. And those can be related to costs or patients. So the mechanics of logistic regression, let's just dive right in and talk about that. So logistic regression is heavily related to linear regression. So let's just quickly go over what linear regression is. Let's remind ourselves. So with linear regression, you can take values of one or more predictor variables and put them into an equation that you found in order to predict what the value for your target variable is. And linear regression finds the equation that gives a best fit line, and it minimizes the error of data points from that line. And so basically you're using predictor variables to predict a value on a continuous spectrum of numerical data. So logistic regression is very similar in that you use predictor variables, you find a linear equation with coefficients belonging to each predictor variable, you've got your intercept, but the output isn't a quantitatively continuous value, rather it's applied to this function, the output of the linear regression, we call it the logit in this case, and it's applied to this function, and what results is an estimated probability. And the probability is the probability that a data point or a patient, and we could say, for example, it's the probability that a patient will fall among one or the other categories. So there's two possible categories with logistic regression. So take, for example, if we have data about heart attacks, and we have data about our patients. Specifically, we have data about blood pressure, so maybe average blood pressure levels over the last year. We can use those and apply them as predictor variables into our function and then get an output of a probability of how likely a patient is to either have a heart attack and be among these orange patients or not have a heart attack and be among these blue patients. So we're using the historical data and the correlation that exists between blood pressure and heart attacks in order to predict the likelihood of heart attack for patients that are new to us and that don't have any history of heart attacks yet. But we can see who's at risk and focus our efforts accordingly in order to improve patient care and decrease costs. So fun fact about logistic regression is you can use linear algebra projection matrices to easily estimate the best fit linear function, and then all you have to do is incorporate this logit function, and you've got a nice logistic regression model. So the benefits of logistic regression, we've talked about the mechanics. Really quickly, the benefits is that they're computationally much simpler to train than other models like gradient boosting machines and neural networks. And another nice thing is you can use logistic regression to help you understand more about your data. So for data exploration, in a way, you can use it to understand more about your data and the relationships between your predictor variables and your target variables, the things you're trying to predict. And so that information, that insight is given by your model's coefficients and their p-values. So you can get an understanding of correlation and significance in that regards. In logistic regression outcome as well, you can just use its binary outcome. You can treat that probability like a threshold and say, is this person likely or not likely to have a heart attack? Along with our example, you can also use that probability and rank it by prediction to answer a question like who is most likely to have a heart attack. So you can kind of identify the highest risk cases and use it that way. So it's a very rich model. There is rich output and rich data associated with it. So one statistical disclaimer is that logistic regression is a linear model. So it needs to have normally distributed data in order to work effectively. And so if your data is not normal, you may want to go with a more non-parametric technique like tree-based methods or neural networks, things like that. So that's all for logistic regression. In summary, let's just say what we've learned. Predictive analytics is good for isolating single case value and risk opportunities in regards to your cost or your patients. It's like a version of linear regression that lets you intelligently classify data into two categories, which would otherwise be difficult to classify. And finally, logistic regression, it has other benefits as well, but it does need normally distributed data. So don't go crazy and just try and use linear methods for everything. But anyways, thanks for joining us, and I hope you've been able to learn some good things.